Hello friends, how are you all today? Have you ever wondered what are Jacobians and how we can use Jacobians to solve the engineering problems? It's coming up right now. Now, let us solve an engineering problem that is V is equal to V of x comma y satisfies the Laplace equation, that is dou squared V by dou x squared plus dou squared V by dou y square equal to 0. This is the question, right? Express this in plane polar coordinates. That is r comma 5. So this is very standard, right? So the question itself is very clear, saying that you have a quantity v which satisfies a Laplace equation dou squared v by dou x square plus dou squared by dou x square equal to 0. We need to write the same equation instead of using x and y in the equation. I'm supposed to use r and phi, right? Where r and phi are very standard, and we know that r and phi, right, they are the coordinates for in the plane polar format. Okay, so let's just write down what are they. So we know that x is equal to r cos phi, and we also know that the y is equal to r sin phi. Right, now we want to write down the expression for dou v by dou x and dou v by dou y. We have to use them to find the dou squared v by dou x squared and dou squared v by dou y squared. When you write dou v by dou x, you use r and phi instead of, right, the regular x and y coordinates should be replaced by r and phi. I should write in terms of r and phi. Now, let us try to substitute the values. So all these, the substitutions we already have. So I'll try to be quick solving this question. So let me directly write one part, that is dou v by dou x is equal to, so first of all we'll write for dou v by dou r, because I'm going to substitute this in the dou v by dou x. Okay, so dou v by dou r is equal to, this is dou v by dou x into dou x by dou r, chain rule. So plus the dou v by dou y into dou y by dou r, right? So x with respect to r, I can actually substitute this directly over here. So this is equal to, what is dou v by dou x? We don't know, we write as this. This is dou v by dou x. Multiply this with the dou x by dou r. X is equal to r cos phi. So when you differentiate this with respect to r, I get cos phi. Plus the next term, it's dou v by dou y, and substitute the differentiation of this y function with respect to r, that is sin phi. Okay, I'm going to call this as equation number 1. Next, I need to calculate the dou v by dou phi, that is equal to a very similar equation is going to come, dou v by dou x into dou x by dou phi plus this is dou v by dou y into dou y by dou phi. So that is equal to dou v by dou x into dou x by dou phi. When you substitute, this is minus r sine phi, the product. So next one is plus dou v by dou y into differentiation of y with respect to phi is r cos phi. So let me call this as equation number 2. Alright, now we will solve these equations in the same way simultaneously. I want to solve these equations simultaneously to get dou v by dou x and dou v by dou y. In terms of the equation should contain only the terms phi, v and r on the RHS. Left hand side will be dou v by dou x and dou v by dou y. So in order to do that, let's solve simultaneously. Okay. Solving 1 and 2. Simultaneously. Let's say I want to go for dou v by dou x. I want to retain that. I want to cancel out the second term, right? So the term containing dou v by dou y I want to cancel out. So I multiply the first equation with r cos phi. So that is r cos phi into dou v by dou r is equal to, right, we have dou v by dou x. I'm multiplying by r cos phi. So this is r into cos square phi plus dou v by dou y into r cos phi into sin phi. This is what happens to the first equation. Very similar to this, let us multiply the second equation, equation number 2, by sin phi. So that gives sin phi into dou v by dou phi, that is equal to, I'm multiplying by sin phi, so I will be getting minus dou v by dou x into r sin square phi plus dou v by dou y into r cos phi to sin phi. Now I can subtract. So when you do the subtraction, these two will get cancelled, right? So I have r cos phi dou v by dou r minus sin phi dou v by dou phi is equal to, I have the dou v by r into dou v by dou x common. I take it out, right? The second term anyway it is positive now because we are doing a subtraction. So this is cos square phi plus sin square phi. So anyway, I know that this term is 1. So as a result, I can write the equation. Therefore, I can, okay, I'll directly write dou v by dou x. Therefore, dou v by dou x is equal to, so anyway, r cancel. So I just have cos phi dou v by dou r minus r goes to the denominator, so I have the sine phi divided by r into dou v by dou phi. So let me call this equation number 3 where I got dou v by dou x. Okay. Similar to this, in order to solve these equations, I need equation 1 and 2 once again. Let us just copy those equations. Right? That is this. Alright, now I want to solve once again. So what I need to do, I need to cancel out the dou v by dou x term in equation 1 and 2. So in order to cancel those terms, I need to make the first term same. So I'm going to multiply by minus r sine phi to the first equation. So that is minus r sine phi dou v by dou r is equal to this dou v by dou x into minus r sine phi into cos phi as a first term. The same thing will get multiplied to this, so that is plus this is dou v by dou y into minus r into sine squared phi. So the second equation I'm going to multiply with the cos phi now. So that means cos phi dou v by dou phi should be equal to, this is dou v by dou x dou v by dou x. There is already minus r into sine phi. I multiply with cos phi. Then this is plus dou v by dou y into r cos squared phi. Now, in order to cancel the first term, I need to subtract them. So when you do so, this is minus r sine phi dou v by dou r minus cos phi dou v by dou phi should be equal to, I have r into dou v by dou y common. I take it out. So when you subtract, the second term becomes negative now. So I'll take a minus also outside, minus r. This becomes once again cos squared phi plus sine squared phi. So anyway, I know this is 1 at a later stage. So I can write the dou v by dou y. Therefore, the dou v by dou y is equal to, so r can minus r will also cancel with the minus r on the left hand side. So this is just sine phi dou v by dou r minus cancel. So plus this is cos phi divided by r into this is dou v by dou phi. Alright, so we already have equation 3 in this format. This is what we call as equation 4. Alright, let's proceed now. So convert these equations both the equations, equation 3 and equation 4, convert them into the operator, right? We already have done such operations, so we are very familiar with converting an equation into an operator. So let's do that, right? Converting equation 3 and equation 4 to operators. Alright, I can simply write I just have to eliminate the variable that is or the function that is v. V can be eliminated. We just have to eliminate. We have to drop it. Then what remains is this dou by dou x. Dou v by dou x is my equation. I just write dou by dou x. Right? So dou v by dou x was cos phi into dou v by dou r, but I just write dou by dou r. V I am trying to eliminate minus, see there was a sin phi divided by r into dou v by dou phi. I just write dou by dou phi. Okay, this is dou by dou x. Next, I write the dou v by dou y. I convert that into this. So dou by dou y is equal to, this is sin phi dou by dou r plus cos phi divided by r into dou by dou phi. This is equation number 5. This is equation number 6. We'll use equation number 5 to calculate the dou square by dou x square. Dou square by dou x square is equal to, because this is one part of our Laplace equation, which is dou square v by dou x square plus dou square v by dou x square. We'll calculate the term by term as an operator, because Laplacian is an operator. So dou square by dou x square, from equation number 5, I can write this as cos phi dou by dou r minus sin phi by r divided by dou phi, multiply this with itself. So it's cos phi dou by dou r minus sin phi by r into dou by dou phi. Okay. Now we just have to be careful when we simplify this, because what we are performing is a multiplication plus an operation. So dou by dou r is an operation, but if you multiply cos into cos, it's a normal term. So, right, dou r by dou r is something different. It has a different meaning compared to multiplying cos phi with cos phi. So let's do this step by step. So let's write as it now. Okay, so this is cos phi dou by dou r into cos phi dou by dou r. Okay, that's the first term. Then first term into the second of the second term, that is this is plus cos phi dou by dou r into minus sin phi. So okay, let me put this into minus sin phi by r, okay, into dou by dou phi. Then the second term into the first term of this. So that is minus sin phi by r into dou by dou phi into cos phi dou by dou r. Then the last two terms, minus will be a plus sine phi by r dou by dou phi into sine phi by r dou by dou phi. In order to simplify this further, we need to understand one point. The point is that the operators will move to the right, and while moving to the right, you are supposed to apply that operator to whatever is present on the right side. Okay, this is the same case when you apply this operator to this function, right? There may be, you may have to apply the product rule, right, or any other versions of the differentiation. Okay, we'll see one by one. So the first term, that is cos phi, I'm supposed to apply differentiation to this product, cos phi into dou by dou r. So cos phi is a constant with respect to r, so it goes out. So just dou by dou r into dou by dou r is dou square by dou r square. So that's my first term, cos square phi into dou square by dou r square. Okay, let's go to the next term, wherein I can see that the cos phi and sin phi are constant with respect to dou by dou r. I'll take it out. So minus, this is cos phi into sin phi, right? Now I apply this dou by dou r to this. There is no sin pi, just remember. Minus also has gone out. Fine. There is 1 by r dou by dou phi. Take it as a product. 1 by r is u, dou by dou phi is v. So differentiation of u and v as a product is u into differentiation of v plus v into differentiation of u. I just have to apply that now carefully to get the answer now. Okay, so that gives me, I'll take a bracket because I have to write two terms now. One is u dv, second term is v dv. Right, when I write the u dv, I understand that there is a 1 by r, differentiation is minus 1 by r square. Keep the second term as it is, that is just dou by dou phi. You don't have to apply the differentiation to the second term, u dv. So this is v du is over. Now I do the other way around. So what I do, I get a plus, keep the first term as it is, that is 1 by r as it is, differentiate the second term. There is already a dou by dou phi. I'm applying dou by dou r to that, right? So I can write dou square divided by, this is dou phi dou r. That's how we apply. Okay, now the next term, I can see that the third term I am multiplying sin phi by r into dou by dou phi of cos phi dou by dou r. So it's very clear that minus 1 by r into sin phi is a constant. That I'm going to take it out from this differentiation. So this is minus sin phi by r. So to take that out, in this part I'm taking it out. Apply this operator onto this. Again, it's u into v rule. So the constant, whichever I want to take, I have taken that out. Now I write a bracket. So let's apply the differentiation. Dou by dou phi, I apply to cos phi. Second term I keep as it is. So cos phi is minus sin phi into second term keep as it is, dou by dou r. And in the next term, keep the cos phi as it is. Right? So that is plus cos phi into, apply the same rule. When I multiply dou by dou phi into dou by dou r, right, I'm going to get a very similar term, which is dou square divided by dou phi dou r. You can write dou r dou phi as well, because from the basics of the partial derivatives, we already have come across many situations wherein you can differentiate it in any order. Whenever you are doing the partial differentiation with the two variables. Okay, so this is the third term, we got it. Then let's go to the fourth term. Fourth term differentiation is happening over here. So the dou by dou phi is being applied to this term. So because since it is a phi, I can take the r to other side because r is a constant form. Okay, but that's possible. So we can take this out. Alright. So when that happens, let me write it in the new line now. So that is, I'll take out the sine phi. Okay, so I'll take the sine phi by r outside. That is plus sine phi by r squared is what I'm going to take it out. Then apply dou by dou phi of sine phi is a cos phi dou by dou phi. Next, plus keep the sine phi as it is, sine phi into dou square by dou phi square. Okay, so this is the expression that we require. All right. This is the dou by dou x square. Now, let's similarly, we have to write the dou by dou y square. Okay, let me write the equation number for this first. I call this as equation number 7. Alright, so I'm supposed to calculate the other part now, that is nothing but dou square by dou y square. Alright, that I'm going to write from, already we know that, I will simply write it. The first, the term we are supposed to use is sine phi dou by dou r plus this is cos phi by r into the dou by dou phi into the same thing. Okay, that is sine phi dou by dou r plus cos phi by r into the dou by dou phi. Okay, let us expand in a very similar fashion. So this is equal to sine phi dou by dou r into sine phi dou by dou r, first term, plus the same thing is multiplying with the last term of the second term, that is sine phi dou by dou r is being multiplied with the cos phi by r into dou by dou phi. The third term is once again plus cos phi by r into dou by dou phi. Multiply this with the sine phi into dou by dou r. And the last term is cos phi by r into dou by dou phi is multiplied with cos phi by r into dou by dou phi. Applying the similar way of differentiation like we did for the dou squared by dou x squared, right? I'll keep writing the answer. We get so sine into sine. Okay, this becomes sine squared dou square divided by dou r squared. Then I take minus cos of phi sine phi. So that is already 1 by r, right? So this is 2 pi r squared divided by dou phi. Keep 1 by r as it is. This is 1 by r. This is dou square by dou phi dou r. Alright, that's the second term. Let's go to the third term. This is plus. So I keep cos phi as it is and I divide by r into. So sine phi becomes cos phi. This is dou by dou r. Keep the sine phi as it is. Differentiate partially. So dou becomes dou square. It is already a dou r. So this is dou phi dou r. And the last term, so differentiation happens with respect to phi, right? So cos phi by r, 1 by r squared. So cos phi becomes a, this is plus cos phi divided by r squared, which comes out. When you differentiate partially with respect to this, there is a, the cos phi is minus sine phi dou by dou phi. Okay, then plus we keep the cos phi as it is. Cos phi dou square by dou phi square. Okay, previous equation was equation number 7. Now we'll call this equation by number 8. Right. So we just have to add them now to get the answer in terms of r phi. So 7 plus 8, equation number 7 plus equation number 8 gives, see, left hand side is dou square by dou x square plus dou square by dou y square. On the RHS, when you add up, right, you will see that most of the terms will cancel. What remains I'll write directly. You can verify this later. So we have dou square by dou r square plus 1 by r times dou by dou r plus 1 by r square times dou square by dou phi square. This is what remains, right? So we know that if you write the Laplace equation in the x, y coordinates, it's already been given. So we can finally write the answer as follows. Therefore, write Laplace equation in polar coordinates becomes, it's like this. So you just have to multiply this with the v. So that is dou square v by dou r square plus 1 by r This is dou v by dou r plus 1 by r squared into dou square v by dou phi square equals to 0 is your equation.